Welcome to this station. We're going to be using flowcharts at this station, and then you're going to be building them. So you're going to have a packet that has all types of squares all types of rectangles and arrows that are going to be green as well as red. This is the flowcharts. This is our visual support that we're going to be supporting students with so that we reduce that frustration level. They have a very conceptual understanding of inverse operations. Your job at this station really is to cut out the arrows and the rectangles so that you have a complete set for a small group. And this is something that you can reproduce in your classroom. Let's watch the process in order. Let's move this out of the way. So we have the variable x. Let's just follow. Multiplied by 2, 2x plus 4. The expression 2x plus 4, all of that equals 6. Now we reverse that order using inverse operations. Instead of adding 4, we subtract 4. 6 subtract 4 is 2. Instead of multiplying by 2, we divide by 2. And we have 2 divided by 2 is 1. So that means our x is equal to 1. And then if we plug that in, we should be able to create a true statement. So at this station, this is what you're going to be doing. So let's take a few seconds to go through and watch the demo video, and then you begin the work of cutting and making and taking for your classroom. Thank you again for being part of this station. So in this station, we're really going to be focusing on this flow chart and helping students really get a feel for developing an understanding of using inverse operations to solve multiple step equations, so multi-step equations. We're going to be using your packet here. You're going to cut out your arrows and your rectangles. There is enough arrows and rectangles to actually have a group of 4. And once they're all cut out, this is what you're going to have. You're going to put them in a little baggie. But each student should have 3 rectangles that are red, 3 rectangles that are green, 3 arrows that are red, and 3 arrows that are green. And it'll be set up in this format. And you'll have this graphic to help remind you of how to set it up. So the PowerPoint or the video demonstration, what we're going to be doing is we're going to be starting with taking our dry erase marker, because these are laminated, and you're going to look at your equation. You're going to identify the variable. You're going to then write the variable on the first red rectangle. Now you go back to that equation and you think to yourself, well, what operation is attached to that particular variable, x? It's being multiplied by 2, so then you can just write multiplied by 2. And so our x is being multiplied by 2, which gives us 2x. And so the students are going to be able to actually, and there's that power behind writing. So we're going to be writing 2x on this particular, and then I'm going to pause for a second, and then you will continue to follow this pattern. So they will be writing 2x. And then they look back at the equation and say, okay, what else is going on? Addition of 4. So we add 4 to it. That gives us this expression, 2x plus 4, and all of that is going to be equaling 6, and that is going to be the equation. So this equation has already been simplified. We don't need the distributive property, and it can be shortened if there's really only, maybe it's 2x equals 6. We wouldn't need this additional step of plus 4 on it, or adding 4 to it. So once we get the equation across the top, then we go back and we start looking at that direct relationship. The inverse operation to adding 4 is subtracting 4. So if we take 6 and we subtract 4, voila, we get 2. Now we go back to our, what is going on here? We have this 2x is equal to 2. See this relationship? Now, how do we undo or use the inverse operation to multiplying by 2? We divide by 2. So again, what we're doing on one side, we're doing on the other side here, we're going to be dividing by 2 to isolate this variable. And when we divide by 2, 2 divided by 2 is 1, and so that yields us what our x is. Our x has now been isolated. X is equal to 1. If we plug that in at any given point in this, 2 times 1 is 2. Put it back up here, 2x. 2 times 1 is 2, plus 4 equals 6 still. So this is a great representation for students to get a feel for how all of these very abstract ideas are related and incorporating that inverse operations to isolate the variable. Now it's your turn.